We've worked with standard form in the past, but we took standard form and we solved the equation for y so that we could put it into slope-intercept form. The reason we did that is because slope-intercept form has two numbers that jump out right from the equation that tell us information about the graph. So slope-intercept form tells us the slope and the y-intercept. And equations written in standard form don't have meaning right off the start. So like we can find information, but it's not showing up directly in the equation. So what we're going to do today is we're going to look at standard form, which is when an equation is written and the x and the y are on the same side. And we're going to use this to find our x and our y-intercepts. So the y-intercept shows up in slope-intercept form, but the x-intercept is going to be the point where it crosses the x-axis. So since any linear function can be graphed with 2 points, the 2 points that we're going to find to graph these today are going to be the x-intercept and the y-intercept. So just as a reminder, the x-intercept is going to be a point on the x-axis, and the y-intercept is going to be a point on the y-axis. So we are solving and we're finding two different points, and from those points we're going to be able to graph these equations. So if I'm looking at a point that is on the x-axis, any point on this x-axis, if I look at a few of them, like here's a point at 2, 0, here is a point at -4, 0, and then another one at like -1, 0. So notice that all these points that are on the x-axis have a y value of 0. So any point on the x-axis is going to have a y value of 0. So to find the x-intercept of this particular equation, I'm going to take the equation that we're working with and I'm going to write it twice, once for the x-intercept and once for the y-intercept. And to find the x-intercept, I'm going to plug in 0 for the y. So all of those points we looked at had a y value of 0. So in the equation, I'm going to replace the y with a 0. So now it says 2x minus 3 times 0 equals 6. So that's helpful to us because anytime you multiply a number by 0, the result is 0. That's the multiplicative property of 0. So once I multiply by 0, this term goes away. It cancels it out because it's 0. So now I have 2x equals 6 as my equation. So this is a one-step equation. Right now it's showing multiplication. So 2 times x equals 6. To get that x by itself, I'm going to do the opposite of multiplication, which is division. So I'm going to divide by 2 on both sides of the equation, and I get that x equals 3. So since the variable I'm left with is x, this is the x-intercept. So on the x-axis, I'm going to go find 3, and I'm going to put a dot there. So the first point that I have on my graph is at 3 on the x-axis. So if I want to write this as an ordered pair, the x value of the ordered pair is 3, and then I said that y is 0. So I'm going to plug in the number in the x spot, and then the 0 goes in the other spot. Next, we're going to find the y-intercept. So to find the y-intercept, we're going to think about the y-axis, and at every point on the y-axis, the x value is 0. So to find the y-intercept, I'm going to plug in 0 for the x. So that'll be 2 times 0 minus 3y equals 6. And the function of multiplying by 0 is that it cancels out this term. So it leaves me with -3y equals 6. So once I solve this one-step equation, I will have the y-intercept. So again, this is multiplication, -3 times y. So I'm going to do the inverse operation of division on both sides to get that y by itself. So I divide both sides by -3, and 6 divided by -3 is -2. So -2 is going to be my y-intercept. So on my graph, I go down to -2 and put my second dot. So now that I have 2 points, I can draw that line. So first I'm going to write this as an ordered pair. We said that the x value we're using is 0 and the y value we found was -2. All right, so now that I have these 2 points, I'm going to draw the line that goes through them. And whenever we use slope-intercept form, we try to put as many points on the graph as we could. Here I only have 2, so I'm just going to do the best I can to draw a straight line through those 2 points. So now this is the same line that I would have graphed if I had put it into slope-intercept form. It's just that I found a different way to get there. So I graphed this one using the x and y intercepts this time instead of doing the work to change it into slope-intercept form. So we're going to look at this with another equation. So doing that same method but with a new equation, I take the equation 1/2 x plus y equals -3, and I'm going to write it out twice. I'm going to use one of the places that I wrote it out to find the x-intercept, and I'll use the other to find the y-intercept. So when I'm finding the x-intercept, I'm going to let that y equal 0. So in this equation, I'm going to plug in 0 for the y. And so the function of that was that it cancels that part of the equation out. So now I have 1/2 x equals -3. Even though it's a fraction, this 1/2 is still being multiplied by x. So to cancel it out, I'm going to use the inverse operation of division. So I'm going to divide by 1/2. So we use the same operation, we just might want to use a calculator to help us figure out what -3 divided by 1/2 is. So -3 divided by 1/2 is -6. So when I divide by 1/2, I get that x equals -6. So this number that I'm left with is my x-intercept. That's going to be a point on the x-axis of my graph. So on the x-axis, I go and I find where -6 is. So this graph only has 5 places, 5 grid lines. So I'm just going to estimate if I extended this a little bit, -6 would be about right here. So I'm going to find where that would be and put my dot on the x-axis at -6. So again, if I wanted to write this as an ordered pair, so every ordered pair has an x value and a y value. The x value is the -6. Then once you get there, you don't go up or down at all. So it's -6, 0 for that ordered pair. Now we're going to use that same equation from the beginning, and we're going to find the y-intercept. So to find the y-intercept, we plug in the 0 for the x. So 1/2 times 0 plus y equals -3. So where I plug in the 0, it cancels out because anything times 0 is 0. And this leaves me with y equals -3, and it's a positive y because of that plus sign. So at this point, the y is already by itself. So this tells me that -3 is my y-intercept. So on the y-axis, I'm going to go to -3 and put a dot. And now I have 2 points, and I can draw the line through it. So this point that I just put on the y-axis, it stayed in the middle. So the ordered pair would be 0, -3. The x value is 0. The y value is -3. So with those 2 points, the last thing I need to do is just draw the line through it. So I draw the line as straight as I can through those 2 points that I've graphed. So each time we're wanting to find the graph of an equation in standard form, we can use this method and we can draw the line between the 2 points. So here, our next equation we're working with is 3x minus 4y equals -12. So I'm going to write that equation twice. The first time I have it written, I'm going to plug in a 0 where the y is. So 3x minus 4 times 0 equals -12. And then wherever I plugged in that 0, I'm just going to cross out that term. So now it says 3x equals -12. So to find that x-intercept, I'm going to divide both sides by the coefficient, which is 3 in this equation. And -12 divided by 3 is -4. So I'm going to go on the x-axis and find where the x value is -4 and put my first dot. So the ordered pair that goes with that x-intercept is -4, 0. So since it's the x-intercept, the number goes in the x spot. Using that same original equation, I'm going to find the y-intercept by plugging in 0 for the x. So 3 times 0 minus 4y equals negative 12, and that's going to cancel out that x term. So it leaves me with negative 4y equals negative 12. So to get the y-intercept, I'm going to divide by that coefficient. So divide both sides by negative 4. And so once I get the y by itself, that is the y-intercept. So the y-intercept for this equation is going to be at 3. So on the y-axis, I find where the y value is 3, and I put a dot. So the ordered pair of this would be 0, 3. The number goes in the y spot because it is the y-intercept. And once I have my 2 points, I draw the line through it, and that is the graph of the equation 3x minus 4y equals negative 12. All right, we've got one more example like this to go through where we're graphing, finding the x and the y-intercept, and we're going to use that same method. After that example, we'll look at a word problem. All right, so on example 4, our equation is negative 4x plus y equals 4. So notice that each time we've written the equation out twice. And sometimes this method that we use for solving these equations is called the cover-up method because you're covering up one of the variables. So whenever I'm finding the x, I'm covering up the y in each equation and then solving. When I go to find the y-intercept, I cover up the x in each equation, and that's from plugging in that 0. So sometimes this is called the cover-up method because you're covering up one of the variables. So if I want to find the x-intercept, then I want to cover up the y. So that's where I'm plugging in the 0 and covering it up. So that leaves me with a one-step equation. So I got rid of the y in this, and that's by plugging in the 0. So that leaves me with negative 4x equals negative 4. So to get that x by itself, I'm going to divide both sides by negative 4. And I get that x equals negative 1. So once I get that x by itself, that is my x-intercept. So the ordered pair of this x-intercept would be an x of negative 1 and a y of 0. So that's going to be a point on the x-axis at negative 1. With the cover-up method, to find the y-intercept, I'm going to let the x equal 0. So that's where I plug in the 0, which results in that first term canceling out. So the equation that's left, once I cancel out that x term, is y equals 4. This equation already has a coefficient of 1, so there's no more solving that we have to do. The y is already by itself. So that tells me that the y-intercept of this equation is at 4. So the ordered pair that goes with this would have the y value of 4 and the x value of 0. So when I plot that point, that is on the y-axis, and I look at where that 4 would be, and I put the second dot. So once I have the x and the y-intercept graphed, then I draw the line through those 2 points. The last example I'm going to look at is a word problem. And then we're going to interpret those x and y intercepts. So this says the Taylor family bought tickets to an outdoor concert by the school band. The cost of a student ticket is $3 and the cost of an adult ticket is $4. They spent a total of $36. This can be represented by the function 3x plus 4y equals 36. So we're going to use the x and y intercepts to graph the function, but first we need to figure out what those two variables mean. So in the equation, I noticed that the coefficient of x is 3. And in the situation, that is the cost of a student ticket. So the variable that's represented by x is the number of student tickets purchased. So the number of student tickets times $3 would tell me how much I spent on student tickets. So on the x-axis, I'm going to label that number of student tickets. Next, notice that the coefficient of y in the equation is 4. And in this situation, it tells me that 4 is the cost of an adult ticket. So the variable y represents the number of adult tickets purchased. So first I'm just going to start out by labeling those x and y axes so that I know what each one represents. In the situation, the last thing given was the total of $36, which is what's on the other side by itself. So now that I know what each variable represents, I'm going to write that equation twice so that I can find each variable. So to find the x-intercept of this equation, I'm going to plug in 0 for the y. So I plug in 0 for the y, and that represents no adult tickets being purchased. So that cancels out this y term. Whenever I multiply it by 0, it cancels it out. So I'm left with 3x equals 36. So this means that all of my $36 is going to purchase student tickets. So to find out how many student tickets I can buy with $36, I'm going to divide it by the cost of each student ticket, which was $3. So this tells me that I can buy 12 student tickets with $36. But that is all of my money, so I have no money left over for adult tickets. So on this x-axis, since the x is by itself, this is my x-intercept. I'm going to go put a dot at 12 on the x-axis. Luckily, this graph has enough space that if I count by ones, 12 is going to be that very last spot on the x-axis. So I don't have to change my scale. I can count by ones. So if I write the ordered pair that goes with this, since the x value was 12, that's going to go in the first spot. And so that means that 12 student tickets can be purchased, but there's no money left over for adult tickets. So all of my money is in student tickets in this first point. I'm going to go back and find the y-intercept now. So to find the y-intercept, I let the x equal 0. So I'm plugging in 0 for the x. So that makes the x term go away. It cancels it out and leaves me with the equation 4y equals 36. So what this equation represents is spending all $36 on adult tickets. So I want to figure out if I spend all of my money on adult tickets, how many adult tickets can I buy? So I'm going to divide 36 by the cost of an adult ticket, which was $4. And that tells me that I can buy 9 adult tickets. So my y-intercept here is 9. So on the y-axis, I'm going to count up until I get to 9. And I'm going to put that dot on the y-axis. So as an ordered pair, since this is the y-intercept, that goes in the second spot. And the first spot is 0 because we canceled out the x. So these two intercepts represent the extremes. If I only purchase student tickets, I can purchase 12. And if I only purchase adult tickets, then I can purchase 9. All the points in between when I draw the line are different combinations of student tickets and adult tickets. But those intercepts represent the extremes where all of my money is spent on either student tickets or adult tickets. So now I'm going to look at these multiple choice options down here and figure out which one is correct. I noticed that the first two are talking about the y-intercept, but in the ordered pair that they gave me, the number is in the x spot. So the vocabulary of it being a y-intercept here is incorrect because these are written as x-intercepts. The number would have to be in the y spot to be a y-intercept. So I'm going to go on and eliminate these two options. So now I just want to read these last two where we're talking about x-intercepts because the numbers are in the x spot. So these are written as x-intercepts, but only one of them is correct. So the x-intercept that we have written down is at 12, 0. So answer choice D is the one that has that one written correctly. So the x-intercept is at the point 12, 0. This means that 12 student tickets and no adult tickets could be sold for $36. So this was that extreme that we talked about where all of our money was spent on student